Today on How It's Made Dream Cars, the Alfa Romeo 4C, one of the world's lightest and most affordable supercars. The 1967 33 Stradale is the stylistic ancestor of the all-new 4C. Long considered one of the most beautiful cars in the world, the Stradale embodies the Alfa Romeo tradition. Founded in Milan in 1910, the company became involved in car racing as early as 1911. In racing, form follows function, and this ethos was central to the design of the Stradale. It's the reason the car remains a timeless classic, and it's the reason it was chosen as the inspiration for the 4C. The new 4C may recall the Stradale on the outside, but the resemblance is only partial. Alfa Romeo has designed and engineered this 21st century supercar to meet a completely new set of criteria. When Alfa Romeo set out to create the 4C, they wanted to build a supercar with an extremely high power-to-weight ratio. This meant they could either increase the power or decrease the weight. Since the other part of the mandate was to make the 4C affordable, it had to be as lightweight as possible. At the heart of the Alfa Romeo 4C is its unique chassis. Alfa Romeo chose to have the Adler Group manufacture this vital component. The Adler Group, located near Turin, has specialized in creating car interiors since 1953. They build the chassis from carbon fiber. This material provides the extreme stiffness required in a sports car chassis, while weighing in at only 143 pounds. The 4C has a monocoque chassis. Monocoque means single shell. Instead of using a load-bearing framework, the skin of the monocoque is the structure. To create this single shell structure, technicians carefully layer sheets or plies of carbon fiber on a form called a die. This process is called lamination. To remove any bubbles from between the layers, the technicians use a special hand tool called a cuneo. As with plywood, the layering of the material greatly increases its strength and stiffness. They now add the core of the chassis. This material is called honeycomb because it mimics the structure of beehives. Once they've added the honeycomb core, the workers layer more carbon fiber over it. When the lamination process is complete, technicians prepare to cure the monocoque in a giant oven. Before they can do that, they must cover the entire structure in a material called release film. The oven is called an autoclave. Before they transfer the monocoque to the autoclave, technicians seal it inside a vacuum bag and connect it to a pump to suck out residual air. When closed, the chamber will pressurize and heat up. The carbon fiber has been infused with a resin. The heat inside the autoclave cures the resin, while the pressure compacts the layers of carbon fiber. A breather cloth between the release film and the vacuum bag allows air to circulate and absorbs any excess resin. When the autoclave has finished its job, workers take the monocoque out and then release it from the die. Next, a CNC machine goes to work. It drills all of the necessary holes, where assembly technicians will attach the monocoque to the rest of the car. It also uses various tools to sand down any areas that require flattening. Using a remote-controlled probe, a technician checks the dimensions of the finished monocoque. A computer ensures that they meet the design parameters. Carbon fiber infused with resin is called prepreg. Among other advantages, using prepreg allows Alfa Romeo designers to incorporate elements like the door pillars into the monocoque. Alfa Romeo has created a new motor for the 4C, which has a maximum torque of 258 foot-pounds. Despite its power, it weighs only 295 pounds because it's made almost entirely of aluminum. Although Alfa Romeo makes the engine block out of aluminum, the piston liners are forged from a special cast iron. The piston liners may start out with a thickness of 2 millimeters, but the finish machining process will reduce them by 50% to just 1 millimeter. When installed and finished, they're so thin you can barely tell they're there. Installing the liners is an extremely delicate operation. First, a robot removes an engine block from an oven. The robot then places the piston liners partway inside the other block. Because this block has just emerged from the oven, the aluminum has expanded, allowing the liners to slide in easily. Jets of compressed air prevent the liners from touching and potentially scratching the walls of the liner openings. Next, a second machine picks them up, aligns them perfectly, and sinks them into position. The robot will then transfer the engine block back to the oven for the cooling process. As it cools off, the aluminum will contract around the cast iron liners. When the oven door opens again, the robot places the finished block inside. It will move through different zones inside the oven, cooling off slowly and evenly. This important step prevents deformation or cracking. Once the engine block is cooled and contracted around the piston liners, they can be finished. A device called the honing machine goes to work. The machining done here is so precise that engineers measure the tolerance in microns. A horizontal machining tool polishes the crankshaft housing. Water mixed with a liquid called cutting fluid helps the finishing machines meet the parameters required by the engineers. The crankshaft is a key element of the new 4C engine. It has 8 counterweights, allowing the engine to rev up to a higher RPM with fewer vibrations. Technicians must ensure that those 8 counterweights are perfectly balanced. They use a computerized system to monitor its movement. Having located the imbalances, technicians program a special tool to drill holes in the counterweights. The location, depth, and number of holes must be determined with perfect accuracy. Once fully balanced, the crankshaft then moves to a quality control station, where a series of instruments measure every aspect of its geometry. Technicians now prepare to install the crankshaft in the engine block. First, an automated camera surveys the crankshaft to make sure all the half bearings and thrust bearings are in place. Next, a robotic arm runs a bead of black sealant around the perimeter of the bottom part of the block. Once the sealant is in place, the top part of the aluminum block goes on. Technicians will then bolt it in position. It's now time to install the pistons. The engine block arrives at this station with the crankshaft already in position and the 4 pistons ready to go. A robot picks up the first 2 pistons and places them inside the liners. A second robot rotates the crankshaft so that it's in the correct position. The robot picks up the remaining pistons and installs them. The second robot ensures that the piston's connecting rods are properly attached to the crankshaft. At the next station on the assembly line, robotic cranes slide along an overhead track and lower a component called the cylinder head on top of the engine. The cylinder head closes into pistons, forming the internal combustion chamber. This is the final step in building the 4C engine. It's now time for a thorough quality control test of the engine. Technicians put the 4C motor through its paces. As the engine runs, they keep an eye on their gauges as they measure 30 different parameters, including power, pressure, and RPMs. As the engine revs, the turbo gets so hot it begins to glow. Although most of the engine is aluminum, the turbocharger is steel. It must endure temperatures as high as 1870 degrees Fahrenheit. Alfa Romeo uses a material called sheet molding compound to manufacture the body of the 4C. Extremely stable and dent-resistant, SMC is 20% lighter than traditional steel bodywork. A worker uses a cutting machine to chop a roll of SMC into strips. SMC evolved from something called fiberglass hand layup. Made of polyester resin, glass fiber, and calcium carbonate, the material is already very light. But to hit the 4C's weight target, Alfa Romeo uses a special type called low-density SMC. The technician begins slicing and stacking the strips to create a kind of layer cake called a charge pattern. This stacking process is important because it ensures optimal aesthetic and mechanical performance for the final product. To ensure that the material meets the quality standards required for the 4C, technicians must employ a high degree of manual skill and pay extremely close attention to details. The glass fibers are 1 inch long. A technician loads the charge pattern onto a mold. When the top half of the mold descends, it clamps down with a force of 660 tons, while heating to 300 degrees Fahrenheit. In minutes, the combination of intense heat and pressure forces the material to take the shape of the mold while curing it in place. The technician brings the newly formed component to a quality control station. Here, he brushes on a special highlighting liquid. This liquid will reveal any faults in the surface of the part. The worker gives the SMC a careful visual inspection to ensure there are no wave patterns or air bubbles. Next, a worker begins to assemble the hood of the 4C. He starts by placing the upper panel of the hood in a specially designed jig. He then carefully removes any dust with compressed air before thoroughly scrubbing and degreasing the surface. Moving to the inner frame of the hood, he begins to run a bead of glue around its perimeter. The technician has already applied a softer glue to the inner perimeter of the frame to stiffen the structure. The worker then lowers the inner frame into place on top of the upper section of the hood. 2 holes in the frame fit over a pair of pins designed to hold it in position. The technician compresses the 2 sections together, ensuring a complete bond. For this part of the assembly process, Alfa Romeo designed a simple, low-tech, and fast process. It relies on manual skill and expertise, allowing the technician to fine-tune the process as he works. The technician clamps the 2 sections together with powerful magnets. He switches on an overhead lamp that emits infrared light to help the glue cure faster. Just 30 minutes later, the glue is hardened enough for the technician to handle it. He quickly removes the magnets and begins to trim off the excess glue with a knife. The 2 parts of the hood are now fully bonded together. The outer section helps define the style of the 4C. The inner frame provides the necessary structural support by adding rigidity, strength, and attachment points. The hood is now ready for the finishing process. Here, using an orbital sander, workers carefully smooth down its surface before applying a coat of primer paint. The workers switch the direction of the light source and wet the surface in order to give the hood a thorough visual inspection. This will help guarantee the 4C looks as smooth as it runs. In between each sanding, a worker sprays the component with a coat of primer paint. Once it dries, it will go back to the finishing department for another sanding. After repeating these steps 3 times, the surface becomes perfectly smooth and flat, ready for the finished coats of paint. Once Alfa Romeo has built the parts, it's time to bring them all together. But assembling an unusual vehicle like the 4C requires skilled craftsmen who have specialized experience putting together unique cars. To assemble the 4C, Alfa Romeo decided to collaborate with Maserati, another legendary Italian car manufacturer. Here at the Maserati headquarters in Modena, a team of expert technicians begins the process by constructing the underbody. They bring together the aluminum front and rear frames with a carbon fiber monocoque. They clamp the three parts into a tool called a reference pallet. They then bolt the underbody together, making sure to tighten the nuts to a torque specified by the engineers. Next, the technicians attach the aluminum roll bar, followed by the rear window assembly. They bond the window to the frame of the car with a powerful structural adhesive. The technicians clamp a custom-built jig to the monocoque. This will help them hold components in the correct position as they attach them to the underbody. The workers now prepare to assemble the windshield. Once again, they use structural adhesive for the attachments. Where possible, the 4C design calls for adhesive instead of bolts, welds, or rivets. The use of adhesive helps reduce the overall weight of the car. The technicians install the roof and clamp it in place for 40 minutes to allow the adhesive time to cure. Once they've attached the body or skin of the 4C, it will head off to the painting department. A large overhead crane moves the painted body to the assembly line. Workers remove the doors, hood, and trunk lid. Then they install front-end components like the cooling unit. This is a stop-and-go assembly line. Every 40 minutes, the car moves to the next station. Next, it's time to bring the powertrain and the body together. Technicians use a hoist, which holds the entire weight of the engine as they install it behind the seat. The reference pallet under the car provides a guide so they can position the part correctly. The brakes, with Brembo fixed 4-position calipers, are dual cast, perforated, and self-ventilated. It takes these high-performance components just 118 feet to bring the 4C from 60 miles per hour to a complete standstill. Now the front bumper goes on with its Alfa Romeo shield. The double exhaust pipe and McPherson rear suspension are in place. The front suspension is comprised of a superimposed wishbone system. Workers mount the rear fender and rear bumper around the trunk, which has a small luggage compartment. An important element of a car's design is its feature line. The feature line of the 4C runs from the lateral intake vents across the surface of the doors. The alloy wheels are now in place. A technician starts the car for the first time and begins testing. She verifies that all of the 4C's electronics are in working order and that the dashboard display functions properly. The rolling wheel on the floor is called a rattle bench. It simulates rough driving conditions. Using this, a driver can fine-tune the car's suspension to eliminate any squeaks and rattles. He starts with the front before switching and tuning the rear suspension. Alfa Romeo used race technology for the 4C suspension systems. Here, nozzles positioned at different heights spray the 4C with water. They subject the car to different intensities of simulated rainfall, including soft English drizzle, spring showers, and tropical downpour. Workers check the interior for signs of any infiltration. A driver now takes the 4C for a spin on a track outside Maserati's Modena plant. The track is designed to be uniformly bumpy. Next, two technicians spend 40 minutes examining every inch of the car's surface for defects. As with some other supercars, Alfa Romeo offers an online configurator, which allows customers to reconfigure the 4C according to their personal taste. Viewers can watch a video clip and change elements like the paint color or wheel tape of the car without interrupting the video. The manufacturing process is complete, and this Alfa Romeo 4C is ready for action. Unbelievably, it weighs less than 2,000 pounds. Capable of revving up to 6,500 RPMs, this supercar can accelerate from 0 to 60 in just 4.5 seconds. A 6-speed gearbox allows for fast, precise control. And like all modern Alfa Romeos, it has something called a DNA selector. This gives drivers the choice of 7 different performance modes, including natural, all-weather, dynamic, and race. As far back as 1939, Henry Ford was quoted as saying, "When I see an Alfa Romeo go by, I tip my hat." If he was alive today, the wind from a passing 4C might blow his hat off before he had a chance to tip it.